For today's lesson, I'd like to start off with a review, since it's been a while since we've been together. In Chapter 5, the first three sections involved slope or rate of change, the model of direct variation, and slope-intercept form. So let's go back in time and review a little of each. When we're talking about writing linear equations, we're going to start off with the y is equal to mx plus b, or slope-intercept form. We found out that there were three different cases. In the first case, we were given the slope and the y-intercept. So given those two pieces of information, we simply go ahead and substitute in, and we would get y is equal to -4 times x plus 6. Replacing the slope with m and the b with 6. Then we found out that we could be given the slope and a point on the line. Let's look at an example at that. Here on the left, I have my slope is -3, and there's a point on that line to 8. So using my model, I'm going to replace my x and y into the model, as well as my m. So y, which is 8, is equal to -3 times 2, and we're solving for our y-intercept b. We'll continue, and we'll isolate our variable b. And we find out that the y-intercept here is 14. So once we have that information, we can go ahead and write the line. Y is equal to -3 times x plus 14. That's another way that we'll be writing our equations. And then we were given 2 points. Given 2 points, we have to first calculate slope. So even though I didn't talk about rate of change or slope, here's where it comes into play. M is equal to change in y2 minus y1, over my x2 minus x1. We're starting off with an easy one here. And we see that we have 8/2 ratio, which simplifies to a slope of 4. Once we have slope, we need our y-intercept. So again, we'll take our y times our slope times our x, which is 4, and solve for b. We'll multiply and subtract, and we'll find that our our y-intercept is -4. Writing the equation now, y is equal to 4x minus 4. This is just a quick review, but hopefully things that you remember how to do. Let's talk about graphing. To graph a linear equation, and if the equation's in slope-intercept form, we can start off by identifying our slope and our y-intercept, which is b, and then we begin our graphing. Always start graphing with your y-intercept, that point on the y-axis. I'm going to keep my pencil here, and I'm going to use that slope and go down 2 and over 1, 2, 3, since it's negative. I technically only need 2 points, but there are times that I will go just a little bit further on that in both directions, simply because when we start graphing inequalities in systems, we want to extend that line. Okay, we see that this is a negative downhill slope, and so is the value of my slope, which is a -2/3. My next graph, y is equal to 2/5 times x, is an equation that starts at the origin. This is a model of direct variation problem. And in direct variation, we say x and y vary directly under certain conditions. That gives us a value of k, which is our constant, and also our slope. So leaving my pencil here at the origin, I'll count up 2 and over 1, 2, 3, 4, 5, and we'll go up 2 and over 1, 2, 3, 4, 5. We'll see that we can extend it again and then connect our points. And again, our model of direct variation passes through the origin. A short review on graphing. Here's one of those examples about direct variation where we tell you that x and y vary directly under certain conditions, and we want you to find the constant of variation. The model is y is equal to kx. They gave me a value of y. They're asking us to identify the constant, but they gave us the value of x. We'll solve for k, and k is equal to -3. The equation then follows that y is equal to -3x. To graph that, simply says start at the origin. Because it's negative, we'll count down 3 and over 1 and connect the points. The problem might be extended just even with one more thing by asking you to evaluate. And if we're given the value of x, we can easily find the value of y by substituting it in. If our constant of variation is -3, we'll just multiply, and we'll find out that when we input -4, our output will be a +12. It gives us a value that would also fall on that line that's graphed. We had a brief discussion about parallel lines. Parallel lines are lines that never intersect, and they have something in particular. They have slopes that are equal or the same. So we want to remember same slope, but different y-intercepts. In order to determine if two lines are parallel, we need to be sure that they're in slope-intercept form, and we notice in both of these equations, the slope is equal to -2, which makes them parallel. If you wanted to do a little proving of that, you would start by graphing your first line, starting at the y-intercept 3, go down 2 and over 1. There would be your line 1. For line 2, I'm going to start at -1 and go down 2 and over 1, and we'll see that these two lines are parallel. Write a line that's parallel to a given line and passes through this given point. The only information I need from the given line is our slope. Now we have the slope and a point. We'll substitute in all these values and solve for b. We'll subtract, and we find out that the value of b, or y-intercept, is 4. Now we have an equation. Y is equal to that -4x, because they have the same slope, plus 4. Here's an example of a set of problems that might start with the question, y is equal to 3x plus 1. Which of the following, if any, are parallel to the given line? That means there could be more than one choice, so let's investigate. The equation must be in slope-intercept form. C and D are already in slope-intercept form, and we know that D is not the same because the slope needs to be 3. C is definitely a candidate because y is equal to 3x minus 1 has the same slope. Let's look at A and B now. We'll start by rewriting A by adding 3x to the other side, and we'll see that these two lines have the same y-intercept, so it is not parallel. It's the same line. It's just rewritten in a different form. So this is not parallel to itself, it's the same identical line. Let's look at the next one. I have 2y is equal to -6x plus 6. And when I divide everything by 2, I get y is equal to -3x plus 3. And that's not parallel. It has a slope of -3. So these are all different applications and ways that we're going to be utilizing these skills. We're utilizing our knowledge of slope-intercept form. We're using our slope formula. We have other problems here we can practice. And in our next lesson, we're going to be talking about the other forms of linear equations. We're going to go and talk about the standard form and the point slope form. So that was our review lesson for today.